So first of all, that question of why to reduce emissions. Well, the first is it's about climate change. It's about how the climate is changing. It's getting warmer. We may have more frequent extreme events. And if we actually look at, this is coming from the IPCC report on global warming to keep it to 1.5 degrees centigrade. And as you can see, the temperature is rising. We've got evidence around the world, and the evidence is that it is human-induced. And if we look to the future, it will continue rising unless we control greenhouse gas emissions. If we control greenhouse gases, and particularly carbon dioxide, we've got a very strong chance. But the more we relax this, the less it is. And that the agricultural gases, methane and nitrous oxide, are important to us keeping to within the bands that the globe wants to keep within. And that's really all that graph is saying, is that we can't exempt the gases that agriculture emits if we want to stick within these global temperature bounds. And just to say that this isn't a global issue that's not going to affect New Zealand. So what we've done here is, this is some work that was published a couple of years ago by the Royal Society, which looks at the temperatures now. So we just look at, as one simple temperature metric, how many days above 25 degrees do we actually have? Lots of places are down in that 20 to 40, less than 20. Manawatu here is around 20-ish, give or take. And so what's going to happen to that? Now this is, these thresholds are very important. If you look at most of our grasses, they've got a temperature optimum in the low 20s, actually slightly less. So if we go to 250, you'll see that large parts of the country are getting into this 40 to 60, 60 to 80 degrees, 80 days above 25 degrees. You then fast forward another 50 years, and you see large parts of the country, particularly in the north, are getting to over 100 days when you're above 25 degrees. That's going into a much more tropical and subtropical climate. So our climate can change substantially. And if you think about the Manawatu, last year, we actually had over 40 days above 25 degrees. And that caused some problems. We actually had a severe drought before Christmas. It changes how you farm. And although there is a cost to reducing emissions, and we should not sort of walk away from that, there is. But if we do not reduce emissions, there's a bigger cost. Right, when it comes to the gases, I think it's really important that we differentiate between these gases. There's greenhouse gases. The three main ones are carbon dioxide, methane, and nitrous oxide. And the agricultural gases, the biological ones, are methane and nitrous oxide. But they're not all created equal. They are different. They behave differently in the atmosphere. Now, a gas, carbon dioxide, absorbs less heat than nitrous oxide and methane, but that it continues for a long time. It doesn't break down in the atmosphere, so it continues to warm. Whereas things like methane, which is on the black line, that has a high warming potential, but because it breaks down, that warming fades off over time quite quickly. And nitrous oxide is somewhere in between. It has a very, very high warming potential, and that warming continues for a considerable period of time. It's somewhere in between methane and carbon dioxide. For convenience, it's quite easy to put these into long-lived and short-lived, with nitrous oxide and carbon dioxide being long-lived and methane being short-lived. And if you actually say, well, is methane really important because it's short-lived? If you actually look at the emissions, say for 2016 from New Zealand, and look at the warming they actually cause, and you'll see that methane, which is the blue line, causes the most warming. That's the gas that we emit. It's about a third of our emissions. That causes the most warming from New Zealand in the short term. If you look at nitrous oxide, it's the smallest of the three. Carbon dioxide causes less warming than methane, but it continues for a long time. And you see that they cross over, where methane is more important in the short term, carbon dioxide is much more important in the long term. And that's a really important concept, because when you in actual fact summarize all that quite complicated information around how gases behave in the atmosphere, first of all, there's something we must always remember. All greenhouse gas emissions cause warming. And that's really important because there seems to be at times people forgetting that. Globally, we need carbon dioxide emissions to go to zero. That's simply because they keep accumulating in the atmosphere. I put 1 unit up today, and then I put another unit up tomorrow. That's 2 units in the atmosphere. Another day, 3 units. And that continues because it takes millennia for carbon dioxide to break down. If I then look at nitrous oxide, behaves quite similarly. It will stay in the atmosphere for many, many hundreds of years. So we can treat it in a very similar way to carbon dioxide. So we need to get those emissions down to zero. Methane is short-lived. And what that means, it doesn't accumulate to the same way, so you do not have to get it down to zero. Very crudely, if it lasts 12 years in the atmosphere, if I keep putting an emitter a ton out, it will get to 12 tons in 12 years, but then in the 13th year, it's breaking down from the first year, so it doesn't accumulate. The warming continues for a couple of hundred years, but it doesn't continue to accumulate in the atmosphere, which means you do not have to get methane down to zero, but, and this is very, very important, reductions in methane will help reduce climate change, because any emission of methane is still warming the atmosphere. One thing I think is really important to stress, and we lose this a little bit at times, is that the agriculture sector gets under pressure because we always say half of New Zealand's emissions come from the agricultural sector. And agriculture gets accused of not doing anything. Do not stand for that accusation, because agriculture is doing something. If you actually, in fact, look at what would have happened if you hadn't done something, our emissions would be about 30% higher. What you've been doing is increasing the efficiency of production so that the amount of gas emitted per unit of product has been going down. So that if you hadn't done that, the emissions would have gone much higher. So you can't be accused of not doing anything. You may not have fully understood that what you were doing was reducing emissions, but it has reduced emissions. And that is incredibly important, because that's the mitigation from efficiency gains. That will not stop, because you always strive for efficiency. It's how you stay in business, and you'll be doing that all the time. Maybe there's even more scope to do it. But given the international targets, given the issues of global warming, that may not be enough on its own. And you'll have to start thinking around, how can we have additional mitigation that goes beyond that efficiency gain? So what can you actually do now? And this is a really difficult one, because I think in the short term, it is very much about that efficiency. And all we can do is point you to some things you can look at in your business, but you know your businesses. So some of the things that we've found out that can reduce emissions, very much looking at the balance between stocking rate and individual animal performance. If you look at what Lincoln University did, a lot of work on actually backing off in stocking rate and increasing their milk yield per cow. And it actually reduced emissions and increased profitability. So there's always looking at that balance. Now, that doesn't say everyone can change it, but it's worth looking at. Looking at shifting to less intensive systems. And looking at really, can I come back a little bit in intensity and still remain profitable? Improving fertilizer. Most of you are probably very keen on fertilizer. It's quite a big cost, but is there scope to reduce emissions? Is there scope to look at different kinds of feed, particularly feeds that have lower N, because that affects both nitrous oxide and N leaching? And is there scope to diversify operations, whether that's small blocks of trees on your farm or actually thinking of a different crop? But I don't want you to think that this is a recipe and you go and pick from it. These are just some suggestions. And the analogy I've been trying to use is that I really like watching track cycling. It's one of the favourite things I love to do is watch track cycling. And Great Britain used to be an absolute also-ran in track cycling. And they got a guy called David Brailsford in 2004, said, we are going to be the top nation in track cycling in the world. And what he said is it isn't about technologies. It isn't about a new square wheel or a round wheel. It's about treating it as a system and looking at every part of that system. And what he did, he broke it all down into every little bit. And they were making changes to the design of the handlebars, small aerodynamic. That made 1/100 of a second. They changed the aerodynamics of the pedal. They changed how they shaved the legs of riders. All things you really do not want to know. And they got them down, but these added up to somewhere like 2 seconds. And they broke nearly every track cycling world record. And they won. They changed all the rules at the Olympic Games so they wouldn't win again. And they won again in 2:12. They changed the rules again and they won again in 2:16. And this was not big technical breakthroughs. It was about treating it as a system and improving small components of that system. And it wasn't about we've got the best riders, because they've done it with a whole load of different riders. It's actually about paying attention. And to me, this is a bit about greenhouse gases. Pay attention to every facet of the business, and small gains will add up to significant improvements. In the future, there may be some big gains. These are the technologies that come along, and everyone can have those because they'll probably be universal. But what are we looking at? Things like breeding low methane animals. And we've already done that with sheep, and they're being tested now in the industry. And they are about 5% less emissions than the normal animal, and there's no productivity loss as far as we can see. In actual fact, they're slightly leaner, so they get a slightly higher carcass weight. But that's across very small numbers. But we're looking at moving into cattle to breed that as well, and we're starting a program this year. Methane inhibitors. These are things, the chemicals you put down the animal's throat, and it can reduce emissions. Some spectacular results, 30 to 50%, and these could be on the market within the next 12 to 18 months. I think some slow release devices that are more suitable, and slow release mechanisms more suitable for grazing animals, perhaps that's 3 to 5 years. But they're coming along. And in the long run, maybe we can vaccinate against emissions. It's actually not an animal that produces things like methane, it's the bugs that reside in its stomach. And you can get the animal to produce antibodies that suppress the activity of those bugs. We've shown we can do it in test tubes with quite good efficacy. We're trying to move it on to say, can we do it in an animal? And animal trials are underway now. But I think that's a 5 to 10 year project. And there could be things that really just mean we can't do it. But that's the sort of work that's going on, and some of the exciting things you may have access to in the future. And that is the end of my brief introduction.